All right, we're starting with 4-1, and we're looking at ratios and proportions. And that's really what the whole chapter is about, ratios and proportions. Or maybe you're thinking, you could talk about ratios and proportions for a whole chapter. Yeah, watch them do it. And there are many different applications of these two concepts. So let me explain here. On page 195, do you guys see that little purple box with those ingredients and the parts per batch? Okay, a typical chocolate bar, and that's why they show you some chocolate out there. Some of you are getting like cravings for it. Don't worry, I won't give you any. But you have some cravings. What goes into a chocolate bar? A typical one has sugar, cocoa beans, milk, and flavorings. So which one do you think is the secret? The flavorings. Because they all have cocoa beans, and you can get it from this place or that, but they all have basically cocoa beans. They'll have sugar, and they have milk for the most part. But the flavorings are where it gets like your variety there. Okay, do you guys know what parts per batch stands for? What in the world is that? Okay, do you think Hershey's, when they make their candy bars, I know that maybe you like them. My wife, she loves Special Dark Hershey's chocolate. That's her favorite. Do you think they make it like a little batch at home? They have all these people mixing bowls and stuff? Yes. No, what are they making them in? Do you know what they're making them in? Robots. These giant vats. I mean, I'm talking giant. I don't even know. I'm not even sure if maybe it could be as big as this room. And they're dumping the ingredients in. They have these giant industrial mixers, and they're getting all those elements stirred up. Okay, they're not doing it in a bowl. But what they do in that giant vat, and it's huge, I can do in my bowl. How? By using proportions. So, for every, and if you're looking at that chart, for every 10 parts sugar, how many parts should I add of milk, approximately? For every 10 parts, I should add how many parts of milk? 4. If I have cocoa beans, 5 parts cocoa beans. About how much flavoring parts should I have? 1. Those are going to form the ratios we're going to talk about at the beginning. So let's talk about what a ratio is. Man, this stuff is easy. If you pay attention, if you just pay attention, it shouldn't be that hard. All right, do you guys see where it says ratio in bold? Okay, it gives you the definition right after that. What's a ratio? It is a comparison of two numbers. That's all it is. Boys to girls, and dogs to cats, milk to cocoa beans. Basketball players to volleyball players. Christian schools to public schools. Planets to moons. Those are all comparisons. Those are all ratios. So ratio is a comparison of two numbers. There are 3 major ways to write your ratios. You got to know all 3. Okay, we're going to use the numbers x and y. You can say x to y. That's a ratio. X to y. You use the word to. You can use x to y. What's that called? Those 2 dots right there. Colon. Very good. X to y. That's another way of writing it down. And then the other way, which is very nice, very common, very useful, x over y. That is also a ratio. So I'm going to make a statement, and I'm going to see if you agree with me or not. All, true or false, all fractions are ratios.
Yes.
True or false?
Yes.
True or false?
True.
Okay, true, yes. So true or false, all fractions are ratios. That's exactly true. This is a fraction. It is also a ratio. It's comparing your numerator to your denominator. Okay? All 3 ways you need to write, be able to write these down. Okay. Can somebody help me out on page 195 to read a little paragraph that says the table above? Can you see that paragraph? Yes, Carson, I see that hand. So where it starts, that paragraph toward the bottom, the table above shows?
The table above shows that for every 10 parts of sugar in a batch of chocolate bars, there are 5 parts cocoa beans. The ratio of sugar to cocoa beans is 10 to 5.
Okay, stop there. All right, you guys are okay with this? we're talking about two parts. What are the two items we're talking about? If you were paying attention, or if you read it. Sugar. Okay, it's talking about sugar to cocoa beans. So go ahead and write this down. Sugar to cocoa beans. And I'm going to make sure I spell that correctly. Cocoa beans. All right, and what is that ratio from parts sugar to cocoa beans? Yep, back there, Jack. 10 over 5. Is that a ratio? Yeah. Yes, you can say 2 to 1. Yep, you could definitely do that. In fact, you're going to do that in your homework. But I just want to look at the raw figure right here. I know. It's tough. 10 to 5. So we're going to say that. All right. Carson, can you keep reading where you stopped? It said you stopped at 10 to 5 and then suppose.
Suppose the company uses 30 pounds of sugar and 15 pounds of cocoa beans in the batch of chocolate bars. The ratio 30 to 15. Is this ratio different than the first ratio of 10?
Okay, this whatever factory or company is going to use 30 parts sugar to 15 parts cocoa beans. They're asking, are these two ratios the same thing? How many of you say yes, they're the same thing? How many say no, they're of course not, they're different numbers? Okay, how can you say that these two are the same thing? How can anyone say that? They're different numbers, guys. You can't just say they're exactly the same, but why can I say that they are the same? Jenna?
Because you're multiplying it by 3.
Yeah, have you done this before, guys, where you multiply a fraction by something over itself to get another fraction? Have you done that before? Have you ever divided a fraction by something over something to get another fraction? Okay, these two are equal. They're equal. Yes, they have different numbers, but same values. Which leads me to my next point, proportions. You guys remember what a proportion is? I said it in the beginning of class. Yes, sir?
Comparison to ratio.
Okay, and I'm going to make it a little bit more succinct. It's right next to the word proportion. An equation stating that two ratios are equal. An equation stating that two ratios are equal. Is that anywhere on this board? Where is it? Yes, ma'am? Yeah, it's 10 over 5 equal to 30 over 15. Is that a statement that two ratios are equal to one another? It is. Is that a true or false statement, though?
Yes.
Is it a true or false?
It's true.
True. Good. True or false? That's true, I hope. Can proportions be false?
Yeah. No.
Mm-hmm.
Yeah.
They can be. They can be. They state it and it's wrong. Okay, so let's look at how we're going to determine whether they're true or false. Turn to page 196. We're going to look at a couple examples. So this is example 1. And use cross products to determine whether each pair of ratios forms a proportion. Have we ever done that before? Oh, I hope we have. 2/3 is equal to 12/18. And this is the eternal debate that I have with my students about how to figure this out. The debate goes like this. Mr. A, you just went through talking about cross products, and Mr. A, I didn't have to do it like that way. I could do it a different way. I'm like, great, good. I'm glad you can do it a different way. Which way do you think I'm going to emphasize? Your way or the cross products way? Not my way, but I'm saying your way or the cross products way. Okay, there's a reason why, and I'll give it to you in just a moment. But how would you do this with cross products? You guys remember? Emery? Not divide, remember cross product. So what does product refer to? Multiply. So what am I going to multiply here?
You can do 2 times 3.
2 times.
2 over 3 times 6.
I see, and I see where you're getting there. But what am I multiplying here with cross products, ma'am?
2 and 18.
2 times 18 should equal. Anybody? 3 times 12. All right, what's 2 times 18? Carson? Sorry, 2 times 18?
2 times 18, 36.
What's 3 times 12? 36. Are these two equal? So, is 2/3 and 12/18 equal?
Yes.
Do those two ratios form a true proportion? Yes. So on this one, use cross products to determine whether each pair of ratios forms a proportion. We would write, you could write proportion, or I'm even going to go with propor or prop. I don't think I'm going to go with prop. Why not? What could prop stand for? Property, and that's not what we're talking about. So just give me something that tells you it's a proportion. See, I was almost going to say property. If it's not a proportion, or these two do not equal, just put not proportion, or no proportion, or not propor. I'm making these up. Yeah. Question?
I just realized that wasn't working.
Was there an easy way to do this problem?
Yes.
What is it?
Couldn't you just do, what's it called? Where you simplify the equation and you do you do like 2 fits into 2. What?
So 2 fits into 12 6 times?
Yeah.
And then 3 times 6 is... Oh, man, that is an easier way. I can't believe it. Oops. Forget what I said. Do B that way. Go. Do B that way. Try it. I dare you. Figure it out. Come on. It's a proportion or not. Boom. What do you multiply by to get from one to the other? Here's a little hint. I don't know. So what's the better way to do this one? Use cross products. This one example is enough to say, yes, you could do it one way, the way we just talked about. Something times the first number should give me the second, but that doesn't always work. So 2.5 over 6. So 2.5 over 6. And then we have 3.4 over 5. Excuse me. I better say that correctly. 3.4 over 5.2. So I'm trying to determine, are these equal or not? I don't know. So if you don't know it off the top of your head, use cross products. Okay, does 13 equal 20.4?
No.
So it does not equal that. And actually, you know what? Let's make this easier. For your answer, you see how they're not equal? Just write that. Not equal. That's your answer. The other one could just say the equal sign. Make it easier on you. Do you want me to keep it that way or make you write it out? You guys good with that? Okay, questions on that? We got time. Go to page 198 and do number 6 on page 198 toward the bottom. Number 6. I don't want your answer just by itself. Don't guess. I want you to tell me why your answer is so. So number 6. Mr. Ray, how do you tell if the answer's... How can you show what your answer is? You have to work it out. Do not just put an answer there because That is not enough. All right, did you guys get those numbers, 8.28 and 1.02? Okay, it's very clear then what your answer is. Are they equal or not?
No.
So what's your symbol? The not equal to sign. Not equal to sign. How many of you got that? And then your final answer, not equal to. That's like a good chunk of your homework already. Okay, let's go to the second part. I'm going to try to get to the last part in a little bit. But anyway, example 4. What does it say to do on example number 4? Ma'am, Emery? Okay, so A. They give me 5 over 4.25 equals 11.32 over M. 11.32 over M. If it says solve, what are they asking you for in this problem? What does M equal? And I don't know what it equals, so how do you figure it out? Use cross products. Just like you did before. You're going to do 5 times M, which is also known as 5M, and then whatever 4.25 and 11.32 multiplied together give me. So go ahead and work that out. We will confirm each other. Oh, my. Oh, that's what's wrong. 2, 2, 2. Okay, sorry about that. How many of you got 9.622? How many of you are not done yet? That's okay. If you're done with number 4A, try 4B, and then I'll work it out with you together. So what I did here is I multiplied, was it 4.25 right here? 4.25 times 11.32 is 48.11. So 5m equals 48.11. Divide both sides by 5, and then that's how I get my 9.622. Okay, on this one you're going to do cross products again, but Mr. Ray, there are two x's. Have we dealt with that before? Yes. Because we're still going to do the cross product, so we're going to do 15 times x is 15x. And then here's where you have to be careful. It's 3 times x plus 5, right? So you're right, 3 times x plus 5. So have you dealt with these equations before? Maybe before the break? I hope so. Okay, so do I have both sides simplified? So simplify them. 15x is good. Distributive property, 3x plus 15. All right, both sides are simplified, but is the variable on only one side or the other? So I think the best way to do is subtract 3x from both sides, which gives you 12x equals 15. Oh no. What do you do to both sides now? Divide by 12. Mr. A, you can have a fraction on these. You sure can. Just make sure it's simplified. 15 twelfths, also known as, okay, yeah, 5 fourths or 1 1/4. Yeah, that's good, or 1 1/4. How many get 5 fourths or 1 1/4? Is it possible to solve those? Yes, I hope so. Yes, sir.
What if you got a fractional answer?
So,
Not a decimal answer.
yeah, 1.25. Mm-hmm. Yeah. Okay, your homework tonight. Is 14 to 31. Is it warm in here? Is it humid in here?
Yeah.
It feels stuffy. And then 39 to 43, and that's pages 199 to 200. Wow. You've already made it to the 200th page. Consider yourselves.
We're old.
Yeah, old or advanced? All right, you still have a few minutes. I'm going to turn off Swivl.